Hello guys, welcome back to my YouTube channel. So today we are going to solve day 18 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1368. Minimum cost to make at least one valid path in a grid. Okay, so in this problem we have given m into n grid. Each cell of grid has a sign pointing to the next cell you should visit if you are currently in this cell. Okay, the sign of grid of I j can be 1. Okay, and 1 means we have to go to the cell to the right. Okay, so 1 means to the right, 2 means to the left, 3 means go to the lower cell. Okay, go down, and 4 means go to the upper cell. Okay, like this. So this is the meaning of these numbers. All right, now after that, notice that there could be some signs on the cells of the grid that point outside the grid. Okay, so you will initially start at the upper left cell. Okay, 0 by 0. Okay, a valid path in the grid is a path that starts from the upper left cell and ends at the bottom right cell, m minus 1 n minus 1. Following the signs on the grid, the valid path doesn't have to be shortest. Okay, you can modify the sign on a cell with cost is equal to 1. You can modify the sign on a cell one time only. Okay, only one time we can do that. Now let's understand this with an example here. So ignore these three pictures. Okay, just focus on this first. Okay, so here see, this is grid given to us. Okay, number of rows is 3 and number of columns is also 3. Okay, so let me draw that. So here 3, right? So okay, and here, all right, and here. Okay, so now let me do one thing here. Let me copy this same. So m into n size. So here let me just write the indexes. So 0 1 2 and here 0 1 2. Okay, and here also 0 1 2 0 1 2 and here also 0 1 2 0 1 2. Okay, so here let me just fill this first. So first row we have 1 1 3, then we have 4 3 and 2, and then we have 3 2 and 2. Okay, so now here let me just add the directions. Okay, 1 means go to the right side. Okay, so here see, 1 means right, 2 means left, 3 means down, and 4 means up. Okay, so like this. So 1 here, 3 means go down. Okay, 2 means go to the right side, 3 means go down, 4 means go up, right, and 3 means go down, 2 means go to the right side, left side, and 2 means go to the left side. Okay, so this is done. All right, so we are going to start from here, right, 0 by 0 cell, and we have to reach to this cell m minus 1. Number of rows is 3 3 minus 1, that is 2, and n minus 1 number of columns is 3, so 2. Okay, so 2 by 2, so we have to reach here. Okay, so we have to keep the cost minimum. Okay, so here if you see, I can move to this cell. Okay, from here, and from here I can move to this cell. Okay, I'm not changing any arrow yet. Then from this cell I can move down, from this cell I can move to this direction. Okay, from this cell I can move to this direction, but here I got stuck. Okay, now I want to move here to this cell. Okay, but instead of this arrow is pointing to this one. Okay, so if I move here, let's suppose, again I have to change this arrow, right, to up direction. Okay, so here if I directly just change this cell, or they change this arrow to this direction, then I can reach to this position, right? Or directly from here also I can change this direction, right? Here, here, then here, then change this arrow into this direction, right? Then also I can reach here, right? So we have to change at least one arrow right here to reach to this destination. Okay, so that simply means that we are going to spend one cost. Okay, you can modify the sign on a cell with cost is equal to 1. Okay, and you can modify the sign on a cell one time only, right? So this is what we need to do, right? So here let me just erase everything. So we have to reach here. Okay, so right now just understand it like this. Okay, minimum cost we have to find. All right, now here let's create one more matrix. Okay, one more grid, and let's name it as min changes. Okay, min changes, and in this min changes, fill everything with infinity in the starting. Okay, everything with infinity, max value of integer. Okay, fill everything with infinity, and here also infinity, infinity, and just this cell fill it with 0. Okay, because we are going to start from here only, right? We are at this particular position only, and at this particular position cost is 0. Okay, that is why I am filling 0. Okay, now see here, from this cell. Okay, now if you see carefully, from this cell. Okay, so we in which directions we can move? From this cell we can move in this direction, okay, and to this direction. Okay, these are the two directions in which I can move, right? So here, from here, if you see, arrow is in this direction. Okay, so I can easily move from this cell to this cell, okay, without any cost. So here I'm going to update this min changes here to 0. Okay, here I'm filling 0. All right, and here, okay, from here I can move to this cell, right? So if I move from this to this, okay, I have to change this arrow, right? So I have to make it this one as 1. Okay, this is done. All right, now after that what we need to do? Okay, so this is done. Okay, so here let's suppose, okay, let's suppose there is one big matrix, okay, one big matrix, and you are here. Okay, you want to reach to this particular cell. Okay, you want to reach to this particular cell. So in how, from how many directions you can come? So you can come from this, okay, from top. You can come from left side, you can come from right side, or you can come from bottom. Okay, if you want to reach to this particular cell. Okay, so here I can say that cost of reaching this cell is equal to cost of reaching to this cell. Okay, cost of reaching to this cell from this cell. Okay, from there is some cell here, from that cell to this cell, what is the cost? Okay, so I want to reach to this cell. Okay, so my cost depends upon this this cost. Okay, this cost, and also the cost, previous cost, okay, with which cost I reached this cell in the past. Okay, so there is one cell here, there is one cell here, there is one cell here. Okay, so my cost is depending on the cost with which I reach to this particular cell, and then from this cell what is the cost I'm taking to move to this cell. Okay, cost with which I am reaching to this particular cell, and then from this cell how much cost I'm taking to move my to my target. Okay, so this is what I'm saying, cost to reach this particular cell, then from this cell what is the cost I'm taking to reach to this cell. Okay, so this is clear. These are the 4 ways, right? So now here, from here, okay, from here I want to move to the bottom. Okay, so there is one way that like we can move like this now. From top I want to move to here, so there is one way I can move like this. Okay, I have to do two options. Okay, I have to move forward or downwards. These are the two options I have. I have to move downwards or upwards. Okay, these are the options I have. Okay, now from bottom if I want to move to the top, okay, from bottom if I want to move to top, so I can move in this direction and in this direction. Okay, so if there is one cell here, so I can move to this and this. If there is one cell here, I can move to this, I can move to this. Okay, there are multiple ways, right? And here directions are not fixed. Okay, directions are not fixed, so we can, it's not like we have to move like this, like this, like this. Okay, or from here, here, here. Okay, like this. So there may be best answer if we move like this. Okay, here, then move downwards, then move downwards, then here, then here, then here, then here, then here, then here, then here. Okay, so this is also, there may be some way. Okay, like this. So here in this C we are moving to this side, right side, we are moving to bottom, we are moving to left side. Okay, right side, then moving to up also, then again moving to right side. Okay, there are many different ways, right? So here, first of all, from, if I'm starting from here, okay, from top, and I want to move to the bottom. Okay, so in that case, here I'm just filling the values. Okay, this is nothing but my forward pass. Okay, let's say forward pass. So here we are going to check the cells coming from the left and top. Okay, so we are checking the cells which are coming from left and top. Okay, so this is done. All right. Okay, so now if I'm here at this particular position, okay, if I am here at this particular position, okay, so now from this cell, okay, so first just do one thing, take first row. Okay, and now we are just filling the first column value. Okay, so it's already filled. Okay, so from here I move to this one. So now let's take this. So from this I can easily move to this direction. Okay, I can easily move to this direction, but here I have to change the arrow. Okay, so here I'm just going to change it to 0, and I'm going to change it to 1. Okay, this is done. So now after that I move to this cell. Okay, this column. All right, one second. Okay, so now I am here at this particular cell. Okay, at particular column. Okay, here. So now here, from here I can easily move to this direction. Okay, and other direction are locked. So here this is infinity, so I'm just going to maintain the minimum value here. So this I'm going to change it to 0. Okay, so here let's change it to 0. Okay, so once this is done, then after that let's move to the this row. Okay, now this row I'm going to start filling column by column. Okay, this and then this. Okay, from here cost is 1. Okay, so from here if I move, I can move to this one direction, I can move to this direction. Okay, so from here if I'm moving to this direction, so here it is 1 initially, previously it was 1. Okay, and now here 1, and I have to change the arrow, so it is going to be 2. So out of these 2, which is minimum? 1 is minimum now, so let it be 1 only. Okay, so from here if I move downwards, so I have to change this arrow. Okay, this is a part, I have to move it downward. So here this cost 1, and in this one I'm adding one more 1. Okay, so here cost is total 2. All right, so now check this. Okay, we are moving like this, then we are going to check this, then we are going to check this. Okay, so this is nothing but forward pass I'm doing. All right, so now after that check this. So from here I can move to this direction, I can move to this direction. Okay, so if I'm moving this, okay, here it is 0 in the past. Okay, so now here 1, and again arrow change, so 2, so 0 is minimum, so let it be 0. From here if you move downwards, so here it is 1, and there is no change to change the arrow, right? So let's change it to 1. Okay, let's change it to 1. All right, now we move to this one. Okay, so from here if I move downwards, so I have to change it to 1. Change it to 1. Okay, this is the best cost now, cost right here 0, and here I have to change the arrow, so it will 1. Okay, initially it was infinity. Now I move to this cell. Okay, here I have to check. So from here I can only move to this direction. Okay, so here can I update this was 1. Okay, now if I want to update, I want to change this. Okay, 2 plus 1 3, so 1 is minimum now, let it be 1. Okay, so now 1, here this is not a way. Okay, so here we can move to this side. All right, so 1, and here I have to change the arrow, so 2, and here it is 1. Okay, here it is 1, so 1 is minimum now, so we just change this one arrow, right? So here fix it 1. Okay, so this is nothing but forward pass approach. In forward pass approach I'm moving to this direction and this direction. All right, so now see here, after forward pass 0 0 0 0 0 0, 1 1 0 1 1 0 and 2 1 1. Okay, so this is nothing but my forward pass. Okay, initially forward pass. Now take, after that this is my forward pass. Okay, now what I'm going to check, I'm going to check the backward pass as well. Okay, what is going to be my backward pass? All right, so here how we are going to update that backward pass. Okay, so now for backward pass, that simply means we are going to check the cells which are coming from the right and bottom. Okay, so from here we have to start. Okay, so here if you see, so right now this is value is 0 0 0 1 1 0 2 1 1. If you move to this direction, okay, so there is not going to be any change. Okay, so here if you see carefully, okay, we are moving from this to this. Okay, and here cost is 1. Okay, and from here it is coming as 1 only, so here I let it be 1 only. All right, now from here you can move to top. Okay, so if you move to the top, so here cost is 0, and now new cost, if I change the direction, okay, so it is going to be 1. Okay, 1 this, and in this one I'm adding 1, so 1 plus 1 2, 2 and 0, which is minimum, so 0. Okay, this is done. All right, so now after that let's come to this column. Okay, we have to move to the top. Okay, until here. So here I want to show you guys one thing. Okay, so that is why I am doing this. Okay, in much detail. All right, so from here you can move to top and this. Okay, so if you move to top, then you have to change this cursor, right? This two up. Okay, you have to change that. So if you want to change it, so here 1, so 1 and 2, so it will become 2 here, but 2 is not minimum now, so I'm not going to change this one. Okay, so now from here if you see, it is 1 here, and here 1, there is not going to be any change here. Okay, it is 2 now, it is 2. Okay, it is 2. From 1 there is not going to be any change in the cursor, right? So here cost is 1 is coming. Okay, so from here see how easily I am moving. 0, here 1 cost, here 1 cost, and here also 1 cost. Okay, still 1 cost remaining. Okay, so now here instead of 2 I'm going to update it to 1. Okay, all right, I'm going to change it to 1. Okay, so this is done. Now we have completed this. Okay, this complete. Now let's start from here. Okay, so from here if you want you can move to up or this side. Okay, so this is backward pass. Backward pass means this, and this forward pass means this and this. Okay, so from here you move up or this. Okay, so if you move to this side there is not going to be any cost change, so here if there is not going to be any cost change. Okay, so here if there is not going to be any cost change, then what is this value going to become? Okay, if you see carefully here, so this is going to become 0, right? It was 1. Okay, but now here if I move to from this, so I see that this is simple arrow. Okay, single arrow pointing this. Okay, so here I can change it to 0. Okay, initially it was 1, but now we can change it to 0 now, right? All right, okay, this is done. So now we reach here, so from here we can move to up and down, up and this direction. Okay, left side. Okay, this direction. Okay, so from here if I want to move up, so I have to change the arrow. So here it is 0 now, so let it be 0. Here also if I want to move to this, I have to change the arrow to 1. Okay, it is already 1 here, so I'm not going to make any changes. Then I reach here, so from here I can move to this direction. Okay, so here 1, and here it is 0 in the starting, so I'm not going to update it. So here if you see 1 0 0. Okay, then I'm going to check from this. So from here we can move to this. I have to change the arrow, so 1. Okay, so here it is 0 now, so let it be 0. So from here if I can move to this direction, so I have to change the arrow 1, but it's 0, so I'll let it be 0. Okay, so now if you see carefully here, this is nothing but my forward pass, and this is nothing but my backward pass. Okay, so now here forward pass and backward pass are not matching. 0 0 0. Okay, if you see here, forward pass and backward pass are not matching. Here it is 0 0 0. First row is matching good, but second row is not matching. Third row is also not matching. Okay, so now what does this mean? So here in the forward pass, okay, you are moving like this only. So there is only one way na, from this cell to this cell, there is only one way. Okay, you are moving like this, like this. So from this cell also you are moving like this, like this. There is no other way to reach. So here you are changing this arrow first, then cost is 1, then you are changing this arrow, then you are reaching to this, so cost is 2 coming up here. Okay, now I'm saying there is a better way to reach to this cell with just one cost. Okay, and that way is just try to find a way in which there is just one cost and we reach here. So see this path now, this. Okay, from here we can move to this. All right, then from here we can move to this, from here we can move to this. Okay, then from here you can move to this. Okay, with just change of this arrow. Okay, like this, then you can simply move this. Okay, so here cost is 1. So that is what I was explaining here, right? There is multiple ways to reach to our destination. This is my source, this is my destination, so there are multiple ways. Okay, there are multiple ways, there are multiple ways. Okay, there are multiple ways to reach. Okay, so that is why here see if my forward pass and my backward pass not matching, okay, with each other, then move forward. Okay, again try to find the route, again try to find, again start with forward pass one more time, again start with backward pass. Okay, so here in the iteration 2. Okay, so here this was my previous state, so here I've just copied this previous state here, 0 0 0 1 0 0 1 1 1. Okay, again I'm doing the forward pass. Okay, same this arrow movement. Okay, all that stuff, forward pass I'm going to do that. Then I will see, I will find out that my forward pass is going to become like this, and my backward pass is going to become like this. So here see in this case, if you see at this particular 0 is coming here, so you see this way, this way, in this way we are directly reaching to this 0. Okay, so here again if you see carefully, my forward pass and backward pass are not matching. Here it is 0, and in the forward pass it is just 1. Okay, it is just 1. Again I'm going to take this final, okay, whatever the final pass. Okay, I'm going to take it as previous state. Okay, so here this is my previous state, this is matching this. Again I'm doing the forward pass, so in the forward pass I see that this is the state, then again I'm doing the backward pass from the last position. Okay, then this is the state, then in the final I will see that this previous state is matching with this one. Okay, both are matching. Okay, this is the latest state and this is also the previous state. So here see both are matching. So if both are matching, then just give the value which is stored at this particular position, and that is going to be the minimum changes. Okay, minimum changes. So in the end, if both are matching, that simply means that no matter how much U-turns you are going to take, you are always going to reach at to this particular cell with this much cost. There is no other way. That's the simple meaning. Okay, so that's what we need to find out. Okay, so in this case time complexity is going to be a little bit very higher. Okay, of n into m square, I think. Okay, so since constant size is very small, I think, so I think we will be able to submit the solution. Let's try that. Okay, so let's write the same story that I've explained. Okay, so we have to create a forward pass and backward pass, all that stuff. Okay, so here first of all, number of rows. Okay, int num rows is equal to grid dot length, num calls is equal to grid of 0 dot length, and then create one 2D array of mean changes, and here in this just pass num rows and num calls num rows, num calls. All right, and then we have to initialize all the cells with the max value initially. Okay, for int row min changes. Okay, so here arrays dot fill, we are just going to fill all the rows with the max value of integer dot max underscore value. All right, and then in the starting I'm just going to fill my first cell. Okay, uh, row 0 column 0. Okay, that cell min changes 0, and here 0. Okay, to 0. Okay, and then I'm just going to run one while loop. Okay, and it is always going to be executed until I break it. Okay, so that's the simple meaning of this. So we are going to store the previous state to check for this. Okay, so here previous state we are always going to store. Okay, this previous state, this previous state, and then I'm going to check if this previous state, after again making any forward pass, backward pass, if still we are seeing the same previous state, then just stop the complete process. Okay, so this is nothing but DP approach. Okay, iterative approach. All right, so here create one array, 2D array, priv state. Okay, and in the priv state we are same length. First of all, new int. Okay, here num rows, num calls. All right, and then just run one loop for int row is equal to 0, row is less than num of rows, and row plus plus. All right, and now just going to copy my min changes to prev state. Okay, so here you can just do prev state row is equal to arrays dot copy of what, copy of min changes. Okay, min changes, and here inside this just pass row. Okay, and here just pass num calls. All right, this is done. Okay, so now we have to check forward pass and backward pass. Okay, so forward pass simply means check cells which are coming from left and top. Okay, so run one loop for int row is equal to 0, row is less than num rows, and here row plus plus. All right, and here for int call is equal to 0, call is less than num calls, and call plus plus. Okay, so this is the same approach that I was doing here now. This. Okay, then we have to check this, then we have to check this, then we have to check this. Okay, so forward pass, and then we have to update backward pass. Okay, min changes array. So this is the same story I'm going to write here. All right, now first check cell above. Okay, so if my row is greater than 0. Okay, if row is greater than 0, okay, then in that case only. Okay, so if you see, if we reach here, so from here there is no value which is going to come from top. Okay, so if my row is greater than 0, that's means here if I'm, so for this, okay, values can come from here. Okay, it can come from here. Okay, that's the simple meaning. So if row is greater than 0, so here min changes, here just write row call. Okay, is equal to math dot min of, just copy this. Okay, now see carefully, whatever the minimum value that is stored, if I'm here now, I'm checking this particular cell, so what is the minimum value here? Okay, check that and compare the minimum. We have to compare minimum. Okay, initial value minimum, and here if I come from top or if I come from this side. Okay, so I have to check two things. Okay, so here I'm first of all I'm checking if I come from top, so here this, and here min changes row -1 coming from top, so -1. Okay, so add this from top, what was the value? Okay, so in this value, okay, I have to add what, I have to add 1 or 0 depending upon the sign. Okay, so here I'm just going to write plus, like this, grid row -1. Okay, top row -1, and here call. All right, so here if it is equal to, okay, so coming from top, so I want to reach to this cell, I'm coming from top. So that simply means at top I need this arrow. So this arrow simply means that 3. So if it is 3, then 0 cost. Okay, if it is 3, then cost should be 0. Otherwise, cost should be 1. That is simple meaning. Alright, done. Okay. Now check cell to the left side. Okay, check cells coming from the left. So here, copy this. Now here my call should be greater than 0. Okay, then we have to update again min changes row call with mat.min row call. Okay, and here instead of row minus 1, I have to row. Here I have to do call minus 1, and here grid of row call minus 1. Okay, so if I'm reaching to this cell from here, so I need an arrow like this. Okay, so that simply means if it value is 1, that means that use 0, otherwise 1. Okay, if it is 1, that's simple. That is done. Okay, so this ends here, this ends here. So this is nothing but my forward pass approach. So this is where it ends. Now same way, backward pass. So here I'm just going to copy this. Okay, this is forward pass. Now this is backwards. Okay, so here for the backward pass. So row here I have to write total number of rows I have. So I have to start from the bottom right corner. Okay, bottom right, this corner. Okay, from here I can move here now. So see this. Okay, then we have to check this. Then from here check this. So here I have to reverse the loop. So here I'm writing num rows. Okay, minus 1, and row should be greater than equal to 0. Okay, greater than equal to 0, and here row minus minus. Okay, same way column is equal to, here let me just copy this. Column is equal to num calls minus 1, and call should be greater than equal to 0, and call minus minus. All right, and here if row is less than, it should be less than num rows minus 1. Okay, same base condition that we are applying here, right? And call should be less than num calls minus 1. Okay, so some base conditions. Okay, then here we have to update same. Okay, mat.min row call. Here min changes row, instead of minus now we have to do plus. Okay, because value is coming from the bottom row. So here this is another incremental row now. This I'm filling this cell. So if this cell is at 1, so this cell should be at 2 now. So here, because grid is like this now, so if cell is available here, so from value is coming from this cell, so that is why plus 1. Okay, so simple maths. Okay, so here if grid row, here row plus 1, same thing, and here all. Okay, if it is equal to 4. Okay, so 4 is nothing but going up. Okay, 4 is going up, so then it is 0, otherwise 1. So same way here. Okay, this is good, this looks good. Here it should be call plus 1. Okay, minor changes, call plus 1. Okay, so if it is equal to 2. Okay, so 2 simply means that we are coming to this. Okay, so we have two options now, go this. So if this, so here from here we have to check the value, so call plus 1. Okay, that's the reason. So if it is 2, then this. Okay, so now this is where this ends, and now just we have to check if there are no changes were made in the iteration, in this iteration. Okay, we have found optimal solution. Okay, so if forward pass and backward pass remains same. Okay, forward pass backward pass remains same as previous state. Okay, simply return. Okay, and return the value at this particular position. Okay, that's simple. Fine, we have to add, that's it. Code ends here. Okay, if arrays dot deep equals. Okay, use this function simply, deep equals. Okay, here pass my previous state array. Okay, in previous state I have already made the copy of the previous min changes array, and new min changes. Okay, new min changes, if both are same, if both are same. Okay, and then in that case simply we have to break the loop. Okay, break the loop. So we are breaking. So here if you see, our while loop ends. Okay, we break it here, and here while loop ends. So here just return what, from our min changes array we have to pass, we have to return the last column and last row. Okay, last rows last column. So here num rows minus 1, and here num calls minus 1. Okay, let's run it and see if that code issue. We'll try to fix that. So yes, so let's try to fix that. Okay, so here's spelling mistake now, changes. All right, let's run it again. Okay, again there's some issue here, also spelling mistake. Let's run it again. So all the test cases has been accepted, right? So here this is case 1, case 2. Okay, so in case 2, let me just write this example: 113 432 113. Okay, here there is 4, so can I modify it? So here let's change it to 4 2 2 4 3 2 and then 3 2 2. Okay, 4 3 2 and then 3 2 and 2. Okay, 4 3 2 and 3 2 2. Okay, let's run it. So our output should be 1. So case 2 output is 1. Okay, so now let's submit it. So this is nothing but DP iterative approach. Okay, so just practice this code. Okay, it's a little bit complex but easy. Okay, so that's what we need to do here. Okay, in this approach. And then can we move to approach 2? Approach 2 is going to be a little bit more easy. Okay, less time consuming than this one. Okay, because in this, if you see, running one while loop. Okay, and inside this while loop we are running row and calls. Okay, so it's going to be very large. Okay, so of nm, okay, n into m running this, n into m, this is also running n into m. Okay, so n into m, this is running, and suppose this while loop true. Okay, this also executes so many times. Okay, n into m times in the worst case scenario. Then what will happen? Then my time complexity is going to be of n into m square. That is very huge, because here if you see carefully in this uh, mm, here if you see the size size is very small, 100. Okay, n and m both are 100. Okay, let's see. So 100, okay, square. So that is why we are able to submit. Okay, so size is small in this case. All right, so this is going to be nothing but 10 raised to power 8, right? So that is why we are able to submit. Okay, because size is very small, right? But we have to optimize our section, right? So let's find out a way to do that. Okay, so you know what is the Dijkstra's algorithm, right? So Dijkstra's algorithm says that we can reach from source to destination using minimum weight cost. Okay, we have to find the cheap path. Okay, using cheap path we can reach from source to destination in a weighted graph. Okay, so I can just assign weight, like if there is an arrow change, just assign weight 1, otherwise just assign weight 0. Okay, and we have to use, definitely we have to use priority queue for the Dijkstra's algorithm, right? So that I should cover first the path where cost is 0. Okay, so first I will try to move to those paths only where cost is 0. Okay, so now let's see how we are going to solve this problem using the Dijkstra's algorithm. So now here, from here only I have to start moving, right? So what we have to do? Okay, so I'm going to reduce our time process now. Okay, I'm just going to make it just of n into m, not of nm square. Okay, so here, okay, so first let's suppose that you are here. Okay, at cell 0 0, let's say. So from this cell, if you move to up direction, okay, if you move to up direction, all right, so here if you move up, okay, so your row is decrementing. Okay, so in the grids, if you see, this is row 0, then this is row 1, and then this is row 2. So rows are increasing here like this, but I'm saying that from here if you move to the here, so row will be decremented. Okay, so instead of 0, if I decrement it with 1, so I can write minus 1. Okay, and I'm remaining the same column, I can write a 0. Okay, so this is nothing but up direction. For up direction, I can simply add minus 1 to 0 to any cell. Okay, and I will move up. Okay, so from here if I move into this, so in this case, so see our columns are incrementing. Okay, so here I'm writing g1 and our row will remain same. So this 1 0 is nothing but, okay, this 0 1 is nothing but my left. Okay, my 0 1 is nothing but my right, sorry, because we are moving to the right direction. This is right, so we are moving right here, right? So if I'm moving here, so my column is decremented, so here 0 minus 1 is going to be the direction for what is this, left, left, yes, left. Okay, and then if we are moving downward, so see my row is incremented 1, from 1 it is moving to 2. Okay, so here I am going to write 1 0. Okay, so these are some directions, okay, that you should know. Okay, so I'm going to create one direction array, because from every particular cell we have 4 options. We can move to 4 different cells. Okay, left, right, up, down. Okay, so this is directions array that I'm going to create. Okay, this is step 1 of this order. Okay, now after that, let's do one thing now. here side by side, let's update, okay, so that you guys don't get much confused. So here int, okay, directions, new int, all right, and here I'm going to pass. So how we are moving, we, if you see the problem statement, so one means uh, to the right side, okay, so I'm going to store this one at 1 minus 1 0 index. I'm going to want to store this 2 at 2 minus 1 1 index. I will show you why. I'm going to store this 3 at 3 minus 1 2 index, okay, in a order. I'm going to store this at 4 minus 1 that's infamous at 3 index, okay. So 1 means 0 means right, okay, so right, how we are moving, right 0 1, okay, it's first right 0 1 here, 0 comma 1, all right, and then here we have to write 0 comma minus 1, all right, and then here we have to move, we have to write 1 comma 0, okay, and then here we have to write minus 1 comma 0, okay. So this is nothing but directions, okay, and then I'm going to use this, okay, then min cost, okay, I'm going to create one min cost instead of min changes, okay, min cost, and I have to use priority queue, okay. So here priority queue, and in the priority queue what I'm going to pass, I'm going to pass int array, okay, pq is equal to new priority queue, and here I have to just creating min heap, okay, and at top I want to write minimum cost first, because I want to cover the path in which cost is 0, okay. I don't want to make my cost right. So here let's suppose a and b are two parameters, okay, and in these parameters I have to sort them based on min heap, right. So here I have to write a of 0 minus b of 0, okay, this is done. So I have to take one priority queue, and in the priority queue, okay, in the starting I'm going to add initial, I'm at 0 row 0 column, and at 0 row and 0 column we have cost 0, okay. So I'm going to pass one int array, okay, and in this int array I'm passing what, I'm passing cost, okay. So since I'm sorting them based on cost, okay, and here I'm writing a0, that simply means the cost is at 0 index, so cost is 0 at row 0 at column 0, okay. So this is some minimum things that we have to do, and here we have to fill same thing, okay. So int, I'm going to iterate over all the rows in my min cost array, okay. Then I'm going to fill that with max value, okay, max value, this is done. Then after that once this is done, then here we have to just update min cost 0 by 0, okay, min cost, I'm taking a min change instead of min cost, okay, this is 0, okay, starting cell. So these are some basic things, okay. Now I will reduce this complete code, okay. Now I will simply reduce this complete code, okay. So here this ends here, okay, if you see this ends here, okay. So here I'm just going to put this in comment section right now, okay, all right. So I will delete this part, okay, but if I need few lines like this line, okay, some lines, so I will just utilize this code, okay. So this is some basic setup that you need to do, okay, for this particular problem. So you know how we are writing directions, okay. Then we have to use priority queue, okay. In the starting we have to pass post 0 because we are at same row same column, okay, 0 0, and then here I'm taking min cost, creating my min cost array, and I'm filling all the values with max value, okay, integer, and that's it, okay. Now uh, using priority queue, okay, so how you run the priority queue in the Dijkstra server. So you are making sure that while my priority queue is not empty, okay, until then we have to just run it is not empty, okay, while my priority queue is not empty, okay. So now first, okay, initially in my priority queue we have this value now, so I'm just going to call this, okay. So int cur is equal to pq dot call, okay, removing this, all right. Now this cur, okay, is consisting of cost, row, and column. So I'm going to create three variables here. Int cost is equal to cur of 0, all right, then row is equal to cur of 1, okay, and then call is equal to cur of 2. Okay, so these are the values that we have in cur. Okay, now from this cell I want to move in all directions. Okay, I can move here, I can move here, I can move here, no, I can move here, no, out of bound, no. But if I'm here, so from here I can move to all the directions. Okay, all right. So here what I'm going to write, for int direction, okay, is equal to 0. All right, and then after that dir is less than 4, dir plus plus. Okay, and inside this new row and new column, how I'm going to find? So I'm saying now that if in this 0 by 0, okay, if I add 0 1, okay, 0 0, and here I have 0 1, so if you do the plus, okay, this part 0, this part 1, so from 0 by 0 0 I'm moving to 0 1, okay, 0 0 I'm moving to 0 1 cell. Okay, that is correct. From 0 1 cell, okay, 0 1 cell, if I want to move, okay, right now let's suppose I'm at 0 1, okay, this one 0 1, I want to move downwards. So for downwards we have to add what, 1 0. So 1 and 0, so here I'm going to add 1 0, okay, 1 total, so 1 1. So see, I'm reaching to 1 1. Okay, that is simple. So here we have to write int new row is equal to row plus, we have to add the directions, okay, coming from the here. So dir, here I'm just going to pass at 0 index, okay, at 0, and this 0 means new row. Okay, so 0 index we have this, and at 1 index we have column now, so that's the reason. All right, int new call is equal to call plus this, right, and here I have to write there, and here I have to write 1. Okay, 1 because this value, right? So this is right. Now we have to you can do one thing now, create one method to check if it is valid. Okay, so from here we can't move here now, so it is out of bound now. So here instead of what I'm going to do, okay, simply I can do one thing here. I can create one private boolean function, okay, to check if it is valid a cell or not. Okay, so private boolean is valid. Okay, so here we have some row, we have, let's suppose, some column, then we have number of rows in total that we have, then we have number of columns that we have. Okay, so here it is going to return true if my row is greater than equal to 0, and row if my row is less than numbers and column should be greater than equal to 0, and call should be less than num of calls. Okay, in that case it is going to return true. So here I'm simply going to write if okay uh, if all right. So here we can pass this is valid. Okay, we can call this method if is valid, and inside this what I'm going to pass, I'm going to pass this a new row. Okay, new row, I'm going to pass this new column. Okay, and here I'm just going to pass the length now that we have num rows and num columns. Okay, so num rows and num columns are coming from here. Okay, so if is valid, okay, this new row, new call, num rows and num columns, okay, if it is valid, then in that case what we need to do, okay, then we have to check if we have to add cost extra 1 or not. Okay, 1 we are adding when we are going to make sign changes, okay, and 0 we are adding if we are not making any sign changes. Okay, this we already know. So here I'm going to check new cost. Okay, new cost is equal to cost at that particular cell, and in that cost I'm just going to check. Now you guys will know why I'm writing this at 1 minus 1 0 index, this is at 1 index, okay, in order, this is at 2, this is at 3. Okay, so here previous cell, okay, previous cell, okay, so here I'm going to check if my dir, okay, this direction, okay, right now I'm at 0 direction, okay, let's suppose 0 direction. Okay, so if my dir is not equal to, okay, now check that particular grid. Okay, grid, okay, grid row row, okay, and here you can pass simply row, okay, and now here you can pass column, okay, row and column. All right, and here you can simply check it, you can subtract -1 from it. All right, okay, so now once this is done, then here where is that, here from here it is coming, right, row and core, okay, from that if you subtract -1, okay, so now you will see that if 0 means coming from here, okay, from this cell to this cell, okay, so this direction, okay, I want to fill this, so here at this cell, okay, direction is 0, so at 0, if this sign, okay, if this sign is like this, okay, then in that case only we have to add 0 now, okay, so here I am checking if from here to here I want to move and this sign is not equal to this one, okay, not equal to this one, so here grid row call, okay, whatever the value inside this, okay, so we can have values 1 2 3 4, okay, so if the value is that for this forward arrow value is 1, right, so from this one if I am subtracting 1, okay, I'm getting 0, okay, let's suppose 1 is here, so 0, so in that case this 0 and 0 both are equal to, if they are not matching, okay, they are not matching, so in that case we have to use 0, otherwise we have to use 1, okay, that is simple meaning. So if dir is not matching with this value, okay, if it is matching then use 0, if it is not matching then use 1, that simply means that there is one other arrow, right, so that's a simple thing, okay, so this is what, and then we have to update if we find a better path, okay, so if min cost is that min cost, okay, let's write it, min cost of new row new column, okay, so new row, copy this, paste it here, copy this, paste it here, okay, if min cost this is greater than new cost, okay, new cost which is getting, we are getting, okay, so if the value already stored value, okay, is greater than this, then we have to update, we have to keep the minimum value now, so here just copy this same line, okay, we have to update it, okay, min cost new row new column is equal to new cost, okay, simple disasters the process, and then in the priority queue we have to add this pq dot offer. So here in the priority queue we are always adding the array, right, to the array, so in this array now we have to, what we have to write new cost, okay, we have to write new cost, all right, and then we have to pass num rows and num columns, okay, so here I'm just going to write num rows, num row should be num row now, should be num row, okay, so we are using the num rows, okay, 1 second, so here not num row, we have to pass a new row new call, okay, that's what I do, new row and new call, okay, this is done, so now that's it, okay, we don't need this actually, so let's try to submit it and see if there is code issue, we'll try to fix that, well that's the thing we have to do, okay, so here there is some issues, so here semicolon missing, let's add that, here also add that, okay, so now here, okay, new int, okay, it's 2D arena, so I have to write like this, all right, now what, new, here min cost, we instead of changes we are using min cost now, min cost, here num rows -1 num columns -1, so good, all right, so there are some code issues, then we'll try to fix that, okay, let's go over the code, okay, so here it should be less than now, okay, let's run it now, this was wrong, okay, so see now our solution is accepted, right, let's submit it. So I hope that you guys are clear with this approach as well, this is nothing but disasters algorithm, okay, so in this we are going to use priority and based on cost wise, okay, we have to write, so here, so this is my diagram, right, initially, so initially we are just going to create one priority queue, okay, in the priority queue we are at 0 0 0, we are going to add in the starting, okay, 0 cost row call, okay, so from here we can move to total either 4 directions, right, this, so these are not valid, so we are going to cancel out, and then here at this direction we are going to check, okay, so here at this particular position if it is 1, okay, if it is valid, okay, so that simply means if the arrow is like this, then we can move with 0 post, otherwise 1 post, okay. So that's what we have to update, okay. And there may be some way like you are moving like this, okay. Then from here you also have options to move here, here, okay. Then you again you are going to process the same cell or not? No. So you can do one thing here, you can add one more condition. If uh, here before interaction you can add that, okay, if main post row and call, okay, if it is not equal to post, then in that case simply continue, okay, because we have already calculated the value in the past, okay, with the minimum cost, okay, we have already processed that. Then why we have to process again cell again, okay. So I hope that you guys are able to understand this problem, and if you guys still have any doubt, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.